Learning goals, welcome to this learning session on classifying and describing statistical data. In this course, we shall address raw data, variables, and basic data types, continuous and discrete quantitative data, categorical and ordinal qualitative data, exploring bivariate and multivariate data, data type summary and application. There will be a quiz at the end to test your knowledge.
Introduction to raw data and variables. Raw data refers to information as it is initially collected in a statistical investigation before any sorting, ordering, or processing has occurred. This unprocessed state is vital because it preserves the original observations, preventing any premature bias or manipulation. Data is always described in terms of variables, which are the characteristics or attributes being measured or observed. These variables can range from simple attributes, like the color of cars or engine size, to more complex measurements, such as the number of people at a football match or the length of time an event takes. For instance, if you're conducting a survey on consumer preferences, the individual responses to each question, before they are tallied or grouped, constitute raw data. This raw form allows researchers to apply various statistical methods without losing the granularity of the initial observations. Quantitative data, numerical measurements. Quantitative data consists of numerical measurements or counts, making it inherently measurable and suitable for mathematical operations. This type of data answers questions like how much, how many, or how often, providing concrete figures for analysis. Examples of quantitative data include measures such as height, weight, age, or the number of items sold. For instance, a population census collects vast amounts of quantitative data, including the number of residents in a household or their exact ages, which are crucial for demographic studies. This data is fundamental for statistical analysis, allowing researchers to calculate averages, medians, and standard deviations, and to perform various statistical tests. The precision of quantitative data enables robust comparisons and the identification of trends and patterns within datasets. Qualitative data, descriptive attributes. Qualitative data, also known as categorical data, describes qualities or characteristics that cannot be numerically measured. Instead, it focuses on attributes, types, or categories, providing descriptive insights rather than numerical values. Examples include the type of car, the color of hair, or a person's favorite holiday continent. This data is often collected through observations, interviews, or surveys, where respondents choose from predefined categories or provide open-ended descriptions. While not numerical, qualitative data is invaluable for understanding context, opinions, and experiences. For instance, analyzing customer feedback on brand preferences or service satisfaction provides rich insights that quantitative metrics alone might miss, helping businesses tailor their strategies effectively. Continuous and discrete quantitative data. Quantitative data can be further classified into continuous or discrete types based on the nature of the values it can take. Understanding this distinction is crucial for selecting appropriate statistical tools and analyses. Continuous data can take any value within a given range, including fractions and decimals. Measurements like temperature, height, or time are classic examples, as they can be infinitely subdivided. For instance, a person's height isn't just 107 meters or 171 centimeters. It could be 170.5 centimeters, 170.55 centimeters, and so on, depending on the precision of the measurement. Discrete data, conversely, can only take specific, distinct values, often whole numbers, and typically results from counting. Examples include the number of students in a class, the number of cars in a car park, or shoe sizes. You cannot have 2.5 students or 3.7 cars. These values are fixed and countable. Qualitative data is categorized into nominal and ordinal types. Understanding these distinctions is crucial for selecting appropriate analytical methods. Qualitative data can be further categorized into nominal, often simply called categorical, and ordinal types, which helps in understanding the level of measurement and the appropriate analytical methods. Categorical data, or nominal data, consists of categories that have no inherent order or ranking. Examples include types of advert, styles of painting, or continents where people went on holiday. Each category is distinct, but there's no logical sequence or hierarchy among them. Ordinal data, while still qualitative, possesses a natural order or ranking among its categories. For instance, positions in a class test, first, second, third, satisfaction ratings, poor, fair, good, excellent, or educational levels, high school, bachelor's, master's, are ordinal. The difference between categories might not be uniform, but the order is meaningful. Bivariate data. Exploring two variables. Bivariate data involves the collection and analysis of two different variables for each observation, with the primary goal of understanding the relationship or correlation between them. This type of analysis is fundamental in many fields, from social sciences to engineering. Classic examples include studying the relationship between exam results and the amount of time spent studying, or the correlation between a person's age and their income. By examining these pairs, researchers can identify patterns, trends, and potential causal links. For instance, a scatter plot is a common visualization tool for bivariate data, where one variable is plotted on the x-axis and the other on the y-axis. This allows for a visual assessment of whether a positive, negative, or no correlation exists, providing insights into how changes in one variable might relate to changes in the other. Multivariate data, complex relationships. Multivariate data extends the concept of bivariate analysis by involving sets of three or more related data values for each observation. This complexity allows for a more comprehensive understanding of phenomena influenced by multiple interacting factors. Common examples include analyzing a person's age, height, and weight simultaneously, or studying the factors influencing house prices, such as size, location, and age of the property. Such datasets are prevalent in fields like economics, biology, and machine learning. Analyzing multivariate data often requires advanced statistical techniques, such as multiple regression, principal component analysis, or cluster analysis, to uncover intricate relationships and build predictive models. These methods help researchers identify which variables contribute most significantly to an outcome and how they interact. Data types, summary, and application. Effectively classifying data is the foundational step in any statistical investigation, as the type of data dictates the appropriate methods for analysis, visualization, and interpretation. Misclassifying data can lead to incorrect conclusions and flawed insights. From raw data to its classification as quantitative or qualitative, and further into continuous, discrete, categorical, ordinal, bivariate, or multivariate, each distinction serves a specific purpose. For example, you wouldn't calculate the average hair color, qualitative, in the same way you would the average height, quantitative. Ultimately, a thorough understanding of data types empowers researchers and analysts to choose the most suitable statistical tools, ensuring the validity and reliability of their findings. This precision in data handling is critical for making informed decisions across all disciplines.
Summary. Well done. You have completed the course, Classifying and Describing Statistical Data. You should now be familiar with raw data, variables, and basic data types, continuous and discrete quantitative data, categorical and ordinal qualitative data, exploring bivariate and multivariate data, data type summary and application. Should you need to revisit any of the topics in this course, please use the menu at the bottom of the screen.